Alright, so this video is about the last two geological provinces that we have in New Jersey, which are Piedmont and Coastal Plain. So here are the things that we're going to be talking about for the Piedmont or the Newark Rift Basins, which has the Mesozoic age. The first one, we're going to be talking about the formation of the Newark Rift Basins or the Piedmont itself. The second one is about the story of the rocks. And lastly, we're going to be seeing some of the basalt flow and igneous intrusions that we have in Piedmont. All right, so Piedmont or the Newark Rift Basin. So the basin itself is called the Newark Rift Basins, but this is the term for the geological province or the physiographic province. Okay, the Newark Rift Basins consist of mostly early Triassic to late late Triassic to early Jurassic sedimentary rocks, such as like this here, shown on this figure right here. But not only sedimentary rocks though, it also has some basalt flow and igneous intrusion as well. The rocks that we have in Piedmont or the Newark Rift Basins, they mostly form at about 200 million years ago. This um, happened to be the time when the supercontinent Pangaea began to break apart. Okay, to form the present day configuration that we are all familiar with today. Okay, and this is the illustration of how supercontinent Pangaea broke apart. So here you have a nice big body of supercontinent right here, and then if you pull this side of the supercontinent that way and here to the right, you will get what we call as rifting of the supercontinent. So during rifting of the supercontinent, it will create this normal faults, numerous normal faults right in the middle, and that would create a big holes right in the middle, allowing a very thick pile of sediments to accumulate in the middle of rifting. Okay. So the processes during rifting of the Pangaea include stretching, crustal thinning, normal faulting, and basin formation that eventually led to the separation, a complete separation of the supercontinent, and create the mid-ocean ridge right in the middle. Okay. Of course, during the formation of this, especially during the stretching and crustal thinning processes, the rift basins will form, and one of the rift basins that form along the eastern North American rift system right here is called the Newark Rift Basin, which is what we have here in New Jersey. This is how the Newark Rift Basins looks like. Again, the Newark Rift Basin is located right here in the middle part of the state, right here. All right. And it's bounded by a normal fault in the northwestern part of the basin. Okay. Um, the normal fault indicates that the block right here in front of that dropped down. So you have a lower elevation right here in the southeastern part of the basin, and that would create a big hole right in front of that fault, right in front of that normal fault. And that big hole will allow thick pile of sediments that accumulate within lake environment. Okay, so we have literally big lakes right here. Okay, right in the middle of the state. And this is how the Newark Rift Basins look like across the three states. I mean, we only see just maybe half of the basin in New Jersey. Okay, but the other half will be in Pennsylvania, and a little bit of it will be in New York. Okay, and this is how the complete and this is how the basin looks like across the three states. And here notice that this red line here on the northwestern part of the basin, these all lines indicate what we call as the border fault of the basin. Okay, again, this is a normal fault, and the fault is dipping towards the southeast. So this region right here, they're all in the hanging wall side of the fault. And this is the simplified stratigraphic column of the Piedmont, New Jersey, or the Newark Rift Basins. And as I mentioned, as I mentioned previously, we always like to start from the bottom top right here. So the river sediments at the bottom would be the very first processes that was recorded in the Newark Rift Basin. And then after that, we get deep lake black shale right there at the top. And then we got some nice successions of shallow lake red shale. And then last but not least, we got some three different events of basalt flow at the top section of the Piedmont. All right. Here is another view of that stratigraphic section that I showed you earlier. Here on the left side, you got the formation names. It goes from Stockton, Lockatong, and Passaic, and all the way to Buntun Formation at the top right there. And here on the right side, you have the sediments and the different types and the different types of sediments and environment that make up the Piedmont or the Newark Rift Basin. So let's start from the bottom. Here is the river sediments. As you can see here, we have some coarse sediments that indicate that we may have some channels of rivers or streams that are happening early during the formation of Newark Rift Basin. And then on top of that, we have some lake sediments that consist of fine grain shell, basically. So these are all fine grain shell. Okay, sometimes the shell can be reddish. That looks something like this, has some nice red color in it. But occasionally we also have some dark colored shell as well. Okay, the color of these shells actually gives you a little bit of clue about the water column of the lake. Okay, if you saw these rocks with red color, that indicates that these rocks were deposited with an environment that has a lot of oxygen. Okay, and that is the reason why it becomes red in color, because there was some oxidation that happened during the formation of these rocks. Okay, and then what about the ones that are dark in color? That simply indicates that we have a deeper water column. So the oxygen on the surface of the earth does not go penetrate deep enough into the deeper parts of the lake. So these dark colored shell represents the deep shell, whereas this red color shell represents shallow water of the lake. This is how it looks like. So again, we have some river system at the bottom, and then on top of that we get some deep lake sediments right here represented by these dark color bands of shell. And then most of the rocks from there, they are mostly deposited in a shallow lake environment. And then don't forget about the three different lava flows at the top, right? And before talking about lava flows, we do also have some igneous intrusion, which is represented by the Palisade Sill. Palisade sills form at about 200 million years ago. That's the age of the Palisade Sill. And remember that sills are intrusive rocks, intrusive igneous rocks. Meaning that these rocks form at the deeper parts of the basin, underneath the surface of the earth. Okay, whereas the extrusive, whereas the lava flows that we have in the Newark Rift basins are extrusive igneous rocks, meaning that they form on the surface of the earth during the formation of the Newark Rift basin. Okay. And there are three different lava flows that we have in New Jersey that are represented by these different colors right here. All right, and one of them is what we got in Orange County. All right, or we got Orange Mountain basalt in Patterson. Okay, so this is the rocks that make up this, that underlies this Great Falls and Pattersons. They are all part of the basalt flow that we have in the Nordic Rift Basin. Now, after Piedmont, we talk about the youngest geological provinces that we have in New Jersey, which is the New Jersey coastal plain. So here are the things that we're going to be talking about: the formation of the coastal plain, as well as what are the story behind the rocks in coastal plain. So the coastal plain, the New Jersey coastal plain, developed during the early Jurassic to Cretaceous time, all the way to present day, actually. Excuse me. Okay, these forms during the formation or the development of the passive margin that started out at about 200 million years ago, all the way to present day. Okay, so the development of New Jersey coastal plain, um, again, it develops into a passive margin, and it actually creates a very big basin, especially offshore New Jersey. Okay, and this basin is part of what we call as the Baltimore Canyon Trough. Okay, so Baltimore Canyon Trough is a large basin that contains a very thick sediments right there. It goes all the way to, I don't know, maybe 8 to 9 kilometers thick of sediments. So it's a very big basin with a very thick sediments in it. And New Jersey coastal plain developed on continental and ocean. Oh, for the New Jersey coastal plain, it developed on continental crust, not in the oceanic crust. But Baltimore Canyon Trough developed on some part of it developed in the oceanic crust. All right, so the coastal plain, it is one of the largest, it's actually the largest physiographic provinces in New Jersey, and it overlaps, the rocks in coastal plain overlaps with the rocks in Piedmont, especially in this region right here. Okay, and it consists mostly of unconsolidated to semi-consolidated rocks. That simply means that these rocks are not fully formed to be, sedimentary rocks. They're still sediments and not rocks yet. Okay. Um, so for the coastal plains, there are some interesting characteristics. First, the sediments actually deep into or deep towards the ocean. All right, so it deeps towards the southeast, and so this is how it looks like right there, and it actually thickens also in that direction. Okay, the sediments outcrops right over here, so we don't really need to go into the deeper part to study these piles of sediments. We only need to go to some of the outcrops that we have in New Jersey in order to learn about the rest of this um, sedimentary rocks that we have in New Jersey. Okay, the maximum, it actually goes pretty thick in New Jersey. It's 6,400 feet thick. And again, it represents the rocks that are Cretaceous in age to Miocene in age. All right, so in order to learn about the processes that are associated with the formation of the coastal plain in New Jersey, we have to learn about the sea level change, okay? Because these rocks, this pile of sediments that we have in a coastal plain, they record the changes of sea level through time since the Cretaceous, okay? In order to understand that, we have to understand the process, these two different processes called the regression. Regression is a process when you have the sea level falls and the shoreline or the beaches go or move towards the ocean. Okay, so the shore migrates seawards that way during regression. Whereas transgression, it will be the complete opposite, right? This happens during the sea level rise. So the sea level goes up. That means that the beach or the shoreline will move landward, okay, in that direction. Okay. All right. So the oscillation of the sea level change actually creates a different vertical records, and that's really what we see here in the coastal plain in New Jersey. All right, so this is just an example of a complete cycle of that regression to transgression cycle. You usually have a cycle that is bounded by two different unconformities at the bottom and at the top. And then after that, you have some different sandstones right here, and then clay stone in the middle, and then we have some other coarser sediments at the top. Okay, so these packages are repeatedly, present within the coastal plain. Okay, so this is what we're going to learn about today. Is just one cycle, and just take a look how it looks like. So the base of the cycle is again is an unconformity, and this is good example of an unconformity right here. Okay, um, that separates the one cycle with another cycle at the top, and at the top of that unconformity, you typically have the transgression sediments that consist of glauconite-rich sediments. Glauconite is a mineral that actually looks, it has a dark green color, and that is the reason why the first sediments on top of the unconformity looks pretty green. And then the second one, it that green glauconite-rich sediments were overlain by clay-rich sediments. Okay, something like this. Now this indicates the start of regression. Okay, so you got the deepening of the basin, and then right after that you get the regression, meaning that the basin now, the sea level. I'm sorry, the sea level now starts to fall again. Okay. So the later regression is represented by the presence of these coarse sediments on top of that cycle right there. So this is typically the sandstone that we find in New Jersey, here in the English Town Formation in Jamesburg, New Jersey. So that would complete our cycle. It goes from unconformity at the bottom, we get some glauconite rich sediments, and then we have some clay rich sediments, and on top of that we have the last pile of sediments, which consists of sandstone mostly. Okay, so I think that will be it for this chapter, and and that's all about the New Jersey geology and the four different geological provinces that we have in New Jersey. And I hope that you enjoy that, to know a little bit about local geology. Okay? Alrighty then. Bye bye now.